I would be willing to bet my life that dev boot camps do not even talk about big O notation, and they probably don't even understand what
If
you
they
just
do,
said.
super high level.
Yeah, but it's really important.
And again, I know I'm getting probably technical with like the big O notation here, right? O of n being it has to loop through every iteration to figure out which one it should be, where it becomes O of 1, which is like when you have like a hashed dictionary or something, like it can, because it knows the memory address, I'm accessing index 5.
Okay, so
5 is always 5.
So I failed college 3 times, and I've failed. I was in first time it was 1 semester, then I went back for another semester a few years later. Then I went to a tech school, but so I have a very shallow like higher ed coding background. But the one course I took taught me about big O notation, and I understood exactly what you were saying. I would be willing to bet my life that dev boot camps do not even talk about big O notation, and they probably don't even understand what
If
you
they
just
do,
said.
super high level.
Yeah, but it's really important because
When you're getting at optimizations and performance, super important.
it affects how your code scales. Like, how does it perform at scale? So for the people that don't know, can you explain super high level? Explain it to me like I'm 5. What is big O notation?
So big O notation is it's essentially it's a math equation that at worst is how's your application going to perform. So usually you'll have like an O of 1, which is the fastest you can do. It's like instant operation. Boom. An O of n, like for an example, is going to be like a loop, like a while loop or for loop where you iterate over every
The
portion.
larger n gets, the slower it gets.
Yeah, the larger n gets, the slower it gets.
But with O of 1, no matter how large n is, it's the same
always
speed. Yeah.
Right. So that's where you talk about like your hash sets or your dictionaries or things like that,
Yeah.
right? Because you're giving it a specific index and it knows exactly where it is in memory.
Yeah. Even like a binary search would that still be an O of 1?
A binary search, if I remember right, that is
Because it's a finite number of iterations.
I think it's an O of log of n.
Okay.
Like it's better than n, but it's not as good as 1.
Yeah, okay.
But like I mean again, but when you have an O of 1 operation, right? Like you have a dictionary, you got your dictionaries, you got your hashes. They cost more, right? They use more memory, they use more resources. So like it's always those micro decisions of okay, like how performant do we really need to be?
So practically speaking, like we're hypersensitive to this problem at work because there's an issue. We do web-based programming, and there's an issue with browsers where a browser will only execute n number of simultaneous calls to a server.
Web requests,
yeah. So in a single page app, you might have a dozen or 24 API calls. Those are handled by the browser. Chrome, for instance, is only going to process 6 or so of those at any given time. So it's going to send up 6 requests asynchronously, wait for the responses, and it'll do another 6. And it might not be that clean, but the idea is it's not like gobbling up your CPU threads with a bunch of simultaneous
and
requests.
Firefox is 8.
Yeah. So if your application doesn't have a known number of requests to the database, O of 1 or O of log n, if it's O of n and n can grow, like
you're just gonna be eating up all your resources.
It's a huge problem. Yeah, and we've seen that or it's 2n, where for every record, or
it makes 2 more calls.
Yeah,
right.
Or it's n of n, and you know when you're building something and your test data is generally pretty small, and you're not cognizant of it's fast. It's really fast when you're building it. Then you put it into production where there's millions of data points, and now all of a sudden you've taken down the production server because you've chewed up all the
you thought was fast. Like, yeah, sure, it's fast for now.
So that's a really good example of something where I think the boot camps can start doing a better job of, is explaining some of those abstract concepts that have like real world implications that are being. This isn't just a thing that we talk about like once in a blue moon. This is something we're talking about every day when it comes to performance optimizations.
Right. And it's not like it's a difficult conversation, right?
Yeah.
And it's a standard that we have on our developers of You have to know how many API requests are being made per page.
Yep.
Again, it could be 1,000,000. I don't care. But it's going to be 1,000,000 every single time.
Yeah.
Right. And then it's the same thing for, okay, now we're on the server. We're about to make our database calls. We need to know how many database calls that's going to be. Now, we use Entity Framework to operate between, so we're a C# Microsoft company, so we're using C# with Entity Framework to our T-SQL server. Sometimes we'll use a start procedure because we need to be more optimal in what we're searching for, what we're operating against. But usually, Entity Framework, good enough. But once you start selecting different data elements out, Entity Framework is trying to give you a benefit of optimizing it. And then as it selects every row, it's making another database call. And that's really kind of where we're hitting people of, right? Because the cost of opening the connection string, the cost of getting the data and sending it across network and then closing that connection,
it's expensive.
It eats up resources super fast.
Yeah. Like there's, and with modern web apps, there's this concept of a connection pool. So it's you're opening and closing, but it's kind of like keeping the connection warm, and an app can have a certain number of connections available. So let's say it's 1,000 connections can be made to the database from the application. If your web application for every user is eating up half of those and you got 10 users using it, most of your users are going to be sitting in line waiting for a connection to be open. And then if the user base doubles for whatever reason, now more are waiting. And pretty soon your users start timing out because they've been waiting in line for one of these available connections to be open and they can't get in. These are problems you don't see in development. You might not see in testing unless you're doing performance load testing, which most companies don't do. So we really rely on the developers to be cognizant of how will this thing run when 1,000 people are on it?
Yeah.
Is it gonna eat up 1,000,000 connections?
Right. So, and just to give a little bit, if you are experiencing this, look at your app server and you're gonna see your CPU and RAM spike.
Yeah.
And you look at your SQL server and you're gonna see your CPU and RAM low. Like that's usually the telltale sign of my queue is getting large. But my SQL looks great.
Yeah, your database server is like, yeah, this is great. I'm dealing with 1,000 people at once, and your app server is like it's like a traffic jam.
Yeah, because they're all waiting in queue. They want to get their turn, and they're fighting for resources.
Yep. So yeah, that's one example of, I think, an area where DevCode camps fall short. Can you?
Honestly, they didn't teach that in college either, though.
They taught it to me. You went to the wrong school.
I did.
No, we both went to UW Milwaukee. I learned that.
Did you go for computer science?
I can't tell you what I went for because I don't remember. But I remember I went to Marquette for a semester and UW Milwaukee for a semester. And I think I learned it at UW Milwaukee.
So I know I learned big O notation at UW. I mean, I only went there. So like I know that I learned that in college. But in terms of like that actual practical experience.
Oh, no. I just inferred that.
Oh, yeah, okay.
Yeah. They didn't explain like how. Yeah, when I learned it at the time, I'm like, this is stupid. Why do I need to know this?
Oh yeah, then you hit the problem and you're like, oh,
this is why it matters.
See. Yeah.
Yeah, this is why it matters.